Hello students, we are going to discuss about today's class electrical measurement and instrumentation. This class is the first class of electrical measurement and instrumentation. In this class, we will first discuss about electrical measurement. What is the concept of electrical measurement and what are the classification of electrical instruments and what basis the electrical instruments, measuring instruments are classified. And first we will discuss what is electrical instruments. What is the concept of electrical measurement? Electrical measurement are the methods or devices and calculations used to measure electrical quantities. Measurement of electrical quantities may be done due to measure electrical parameters of a system. To measure electrical parameters of a system, we use the electrical measurement concept. Measurement of electrical quantities may be done to measure electrical parameters of a system. We can say tests and measurements are important in designing and evaluating, maintaining and servicing electrical circuits and equipments. In order to detect electrical quantities such as voltage, current, resistance, power, and it is necessary to transform an electrical quantity or conditions into a visible indications. This is done with the measurements in indicate electrical quantity. This is done with the aid of instruments that indicate the magnitude of or either magnitude or quantity either by the position of a pointer or over in the form of a decimal number or the moving the pointer over a graduate scale. These two types of instrument is used in electrical measurements. We can say the electrical measurements is the measuring of electrical parameters such as current, voltage and power, resistance. These are all the values or the parameters which is measured in electrical instruments. Before going to the electrical instruments, we can understand, we have to understand certain terms before going to study about the electrical measurements. First, we have to study what is accuracy. Accuracy is the closeness between the true value and the measured value of an instrument. The closeness with which an instrument reading approaches the true value of the quantity being measured is called accuracy. Generally, accuracy is determined as the maximum amount by which the result differs from the true value. Then precision. The term precise means clearly or sharply defined. Precision is a measure of reproducibility of measurement. Then the term comes errors. Errors, the deviation or the change of value obtained from measurement from the desired standard value. The deviation between the observed value or the measured value and the standard value. Mathematically, we represent error is equal to obtained value or the reading value or the measured value minus the standard reference value. A standard reference value is given, and when we subtract the obtained or the measured value from the standard value, we will get the errors. Then errors, gross errors, or what are the types of, then we will study what are the types of error. Gross errors, these are the errors due to human mistake. Gross error are the errors which arises due to the mistake of the those who are doing the experiments, or the humans, or with the people who are doing the measurement. Then systematic error. A systematic error, a constant uniform deviation of an instrument, is as systemic error. Constant uniform deviation of an instrument, which is called systemic error. Systemic error is further divided into two types. One is static error and the second is dynamic error. Static error. The static error of a measuring instrument is the numerical difference between the true value of a quantity and its value as obtained by measurement. That is called static error. Then dynamic error. It is the difference between true value of a quantity changing with and value indicated by the instrument. That is called dynamic error. The dynamic errors are caused by the instrument not responding fast enough to the follow the change in the measured value. The frequent change in the measured value, when the instrument doesn't respond to the frequent change in the measured value, the dynamic error comes. Then it becomes random error. The cause of such error is unknown. Randomly it occurred. It may be for any reason, but randomly the error occurs is known as random error. The cause of such error is unknown or not determined in the ordinary process of making measurement. Then types of static error. Static error is further divided into further divided into three types. The first one is instrumental error. The error which arises due to the mechanical construction friction is varying in various moving components is called instrumental error. Generally we can say the error which arises due to the mechanical construction of the instrument is known as instrumental error. Then environmental error. Environmental error, the error are due to the conditions of environmental factors or external factors to the measuring devices, which includes all the conditions in the area of the surrounding the instrument, such as effect of change in temperature, humidity, electrostatic field, and it can be avoided by providing air conditioning, use of magnetic cell. These are the two methods which will be followed for the eliminating of environmental error, for the elimination of environmental factors which will cause environmental error. Then the third comes under the static error is observational error. The error introduced by the observer. These are the errors are caused by the habits of the observer. The error which will arises due to the behavior, due to the wrong observations of the observer is called observational error. And these are the errors which will be comes under the measuring instrument, which will give the measuring errors. Now it comes classification of measuring instruments. Measuring instruments are classified according both the quantity measured by the instrument and the principle of operation. There are three general principles of operation. According to the principle of operation, what are the three general principles of operation? These are: first, electromagnetic, which utilizes the magnetic effect of electric current. Three principle comes: electromagnetic principle, electrostatic principle, electrothermic principle. In electromagnetic principle, we utilizes the magnetic effect of electric current. In electrostatic principle, we utilizes the forces between electrically charged conductors. And electrothermic, which utilizes the heating effect for the measurement of electrical quantities. Electric measuring instruments and meters are used to indicate directly the value of current, voltage, power or energy or etc. other factors. An electromechanical meter that can be connected with additional suitable components in order to act as an ammeter or voltmeter. The most common analog instrument or meter is permanent magnet moving coil instrument, PMMI, permanent magnet moving coil instrument, and it's used for measuring a DC current or voltage of an electric circuit. PMMI instruments are used for measuring DC current or voltage of an electric circuit. Then the term will define sensitivity. Sensitivity can be defined as a ratio of a change output to the change input at steady state conditions. At steady state conditions, the ratio between the input and output. What is the change in the input and the output? The ratio defines the sensitivity of the instrument. Then resolution. Resolutions are the least increment value of input or output. Least incremented value of the input or output that can be detected, caused, otherwise discriminated by the measuring devices. Then tolerance. Tolerance refers to the total allowable error within an item. Total allowable error within an item. We can define tolerance. This is the typically represent as positive or negative value of a nominal specification products can become deformed due to the change in temperature, physical parameters or physical factors, temperature, humidity, which lead to material expansion and contraction or due to improper feedback from a process control device. These are such it necessary to take errors into consideration with regards to design value in manufacturing. Then we will discuss what is the classification of measuring instruments. What are the classification of measuring instruments? Measuring instruments are classified into 7 types. The first one is absolute instrument, absolute and secondary instrument. The second one is analog and digital instrument. Then the third one is mechanical, electrical and electronic instruments, manual and automatic instruments. Fifth one is self-contained and remote indicating instrument. Then the self-operated and power-operated instruments. Then deflection and null output instruments. Now we will discuss all the 7 instruments, measuring instruments. These are in this manner the classification of measuring instruments are to be done. We will first discuss absolute instrument and secondary instrument. Absolute instrument, which measures the process variable directly from the process without the use of conversion. Without conversion of the quantity, the process in which we will measure the variables directly is known as absolute instrument. Such instruments do not require comparison with any other standards. The tangent galvanometer is an example for the absolute instruments. These instruments are used as standard in lab and institutions. In the lab and the institutions, we are using the instruments, electrical measuring instruments. These instruments are known as absolute instrument. Now coming to secondary instrument. Absolute instrument, otherwise known as primary instruments. Next come to the secondary instruments. These instruments are so constructed that the deflection of such instruments gives the magnitude of the electrical quantity to be measured directly. These instruments required to calibrate with respect to the standard instruments. These instruments are usually used in practice. In our practice, we used secondary instruments. Secondary instruments are further classified as indicating instrument, integrating instruments, recording instruments. First, we will discuss what is indicating instruments. What are the indicating instruments? Indicating instruments, those instruments that measures the or measures and indicates the magnitude of the electricity, which indicates the magnitude of the electricity is known as indicating instrument. Then the indications are given by a pointer moving over a calibrated scale. We will obtain the indication by the pointer moving over a calibrated scale. Ordinarily, ammeter, voltmeters and wattmeters, frequency meters, power factor meters, etc. falls into this category. We can say ammeter, voltmeter, wattmeter, power factor meter, multimeter are the example of indicating instruments. Then we come to the integrating instruments. Integrating instruments are those which measures the total amount of either quantity or electricity or electrical energy supplied over period of time. Over a period of a time, certain period of time, the instruments which measures the total amount of quantity of electricity is known as integrating instruments. Then recording instruments. Recording instruments are those instruments which record continuously the variation of the magnitude of the electric quantity for a definite period of time. Such instruments are generally used in powerhouses where the current, voltage, power, etc. are to be maintained within a certain acceptable time. Certain acceptable time within the instruments record continuously the variation of the magnitude of the electrical quantity is known as recording instrument. Then the second one is analog and digital instruments. First we will discuss primary or instruments, then secondary instruments. Now we will discuss analog and digital instruments. The signal of an analog unit is vary in a continuous fashion and can take on an infinite number of values in a given range. And analog instruments frequently vary their values or the parameters in a given range. They frequently changes their values. We measured the digital instruments are those instruments, the digital signals that are vary in discrete step and that take a finite number of different values in a given range are digital signals corresponding to the instrument are digital type. In analog signal, that the signal varies frequently, but in digital it is a certain range of time. Within a given range of digital signals, the parameters vary, the signals vary in a discrete step. This is the basic difference between analog instrument and digital instrument. Digital instruments have some advantages over analog instruments in that they have high accuracy and high speed of operation. Digital multimeter, which are using in a laboratory, is an example of digital instrument. Then the thirdly we will discuss mechanical, electrical and electronics instrument. Mechanical instrument. Mechanical instruments are very reliable for static and stable conditions as they use mechanical parts. These instruments cannot faithfully follow the rapid change which are involved in dynamic instruments. Mechanical instruments are used, mechanical parts are used, that's why it will not accept the rapid change of value which are involved in a measuring instrument. But they are very cheaper and cost and durable. Cheaper in cost and durable. They are very reliable. Then electrical instruments. When the instrument pointer deflection is caused by the action of some electrical methods, then it is called an electrical instrument. The time of operation of an electrical instrument is more rapid than that of mechanical instrument. Then it is called to electronic instrument. Electronic instrument, the instruments are semiconductor devices. The instruments used semiconductor devices is known as electronic instrument. They are very fast in response. Electronics instruments are very fast in response. In electronic devices, since the only movement involved in the electrons, the response time is extremely small, owing to very small inertia of the electrons. Then the fourth one is manual and automatic instruments. Manual and automatic instruments. In case of manual instruments, the services of an operator are required. Such example, you can take an example of measurement of temperature by a resistance thermometer incorporating a Wheatstone bridge in a circuit. That is the manual control of an instrument, that is known as manual instruments. When the automatic instrument, an operator is not required. In that case, operator is not required in case of automatic instruments. Such as example we can give the measurement of temperature by mercury in glass thermometer. Glass thermometers, when measures the temperature, it will automatically measures the temperature. The manual control or operator is not needed. That is known as automatic instrument. Then the fifth type of measuring instrument is self-contained and remote indicating instruments. What is this? Now we will discuss self-contained and remote indicating instruments. A self-contained instrument has all its different elements in one physical assembly. In one place, all the physical elements of this instruments is integrated, differentiated, or the different element in one physical assembly. In a remote indicating instrument, the primary sensing element may be located in an adequate long distance from the secondary indicating element. Remote sensing instruments, the primary instrument or the secondary instruments are far away from each other. Such type of instruments are finding wide use in the modern instrument technology by the remotely controlled indicating instruments. Then the sixth one is self-operated and power-operated instrument. Self-operated instrument, which will operate, do not need any outside power for its working. The self-operated instrument do not need any outside power supply for its working. That is known as self-operated instruments. The output energy is supplied fully or almost wholly by the input measure. Dial indicating type instrument belongs to this category. Dial indicating instrument is an example of self-operated and power-operated instruments. Then we will discuss power-operated instrument. Power-operated instrument means which will need external power for its working. Self-operated doesn't need external power for its working, and power-operated instrument needs external power for its working. External power can electric current, hydraulic or pneumatic energy. In such cases, the input signal supplies only an insignificant pointer of the output. Then the last one, deflection and null output instrument. In a deflection type instrument, the deflection of the instrument indicates the measurement of the unknown quantity. The unknown quantity which we will measure, it will indicate the value of the instrument in the instrument by deflection method. The measured quantity produces some physical effects which deflects or produce a mechanical displacement in the moving system of the instrument. An opposite effect is built in the instrument which opposes the deflection of the mechanical displacement of the moving system. The balance is achieved when opposing effect equals the actuating causes, producing the deflection or the mechanical displacement. Permanent magnet moving coil type instrument, moving iron instrument. These are the types of instrument which are examples of the category. deflecting type instrument. Then in null type instrument, a 0 or a null indication leads to the determination of the magnitude of the measured quantity. The null condition depends upon some other known conditions. These are more accurate and highly sensitive as compared to deflection type instrument. A DC potentiometer is an example of null type instruments. So, this is all about the classification of measuring instruments. There are 7 types of measuring instruments, electrical measuring instruments. In this class, we will discuss accuracy, precision, sensitivity, oscillations, and errors, what are the types of errors, and what are the classification of electrical measuring instruments. In how many ways the electrical measuring instruments are classified. So, we will conclude this class with this. In next class, we will cover types of torques acting in a measuring instruments. Thank you.